Okay, so this is day 8 of Earth and Space, and let's go ahead and jump on in. So question 1, which of the following landscapes is most likely located far away from a tectonic boundary? So I need to look at this. I know that A are mountains, and that's going to be when two land plates, continental plates, converge or collide. Here I have a volcano. That usually happens when I have subduction, which is when an oceanic plate is colliding either with a continental plate or another oceanic plate. And here, what's very interesting about this picture is you can see the railroad tracks are kind of all messed up, and that is from faults. That's from earthquakes where two plates slide past each other. And here I have sand dunes, and sand dunes are really caused by weathering, wind carrying sand. So the best answer choice there was B. Miguel School is located. Well, we got to see what's happening where Miguel School is, and it looks like we're having a tsunami there and earthquakes. Tsunamis are caused by earthquakes that occur in the ocean. So earthquakes are always going to be near a plate boundary, specifically where plates are sliding past each other. If, number 3, if I look at a map of the Earth from 100 million years ago, it would look much different than today. And this is because it has nothing to do with gravity forces from the moon and sun causing the continents to move. Erosion and weathering has changed the shape, yes, but not the location of the continents. That's a no-no. B, life forms and organisms living on Earth have caused the landscape to change. No, we can't move continents. But the convection, the circulation of magma underneath the Earth's crust, yes, that is the whole point of plate tectonics. Number 4, some parts of the Himalayas are growing higher as much as 1 centimeter per year. The Himalayas are huge mountain ranges. What's causing that fast vertical growth? Vertical means up and down. Subduction zone is near the mountain chain. No, that would be creating volcanoes. Huge underground geysers, that's water that gets trapped, groundwater that gets trapped underneath. Nope. Sediments, nope. Two continental plates colliding, absolutely. Two continental plates colliding create mountains. Number 5, this is a picture of the Mississippi River, and you can see it's a great picture where it's creating this lovely delta where these sediments are being deposited into the Gulf of Mexico. So what process is occurring at point A? And point A is right here at the very beginning of where that river and river systems are carrying sediment into the ocean. Solidification, that has nothing to do with anything. That's where rocks solidify and become harder over time to form sedimentary rocks. Deposition is where I'm depositing the sediment. That is what's happening down here. Down here I have deposition occurring. Precipitation is rain, and that has nothing to do with this. So your best answer choice is erosion, because erosion has to do with moving of the sediments. All right, number 6. What would happen to the current river delta at point B over time? Well, I need to see what's happening, what's changing. What's changing is the Mississippi River may jump its banks near point A during a big flood and form a possible channel, new river channel over here dumping into the ocean. If that were to happen, water is then rerouted from the Mississippi down this way, and you get a new delta here, but this would stop occurring. So this delta right here where point B is would actually begin to shrink. It's going to get smaller because the ocean currents are going to be able to carry those sediments away. However, over here where a new delta would be forming, that delta would be getting larger. So what process is occurring at point B? We've already talked about that. That is deposition, where the sediment is actually depositing right here. And you can actually see the sediment being deposited into the ocean. Number 8, which of the following discoveries does not is that clue word, necessarily support the theory of plate tectonics? Well, we know fossils were used. That's what Alfred Wegener did in continental drift, and we know continental drift was certainly used to support plate tectonics. We know early sonar used in World War II helped the oil developers, drillers in the 1970s when they discovered that the ocean floor was actually spreading apart in the Atlantic Ocean, seafloor spreading, and that actually is what led to the theory of plate tectonics. We know that the puzzle pieces, the shape of Western Africa, is very similar to the east coastline of South America. Many different species of dinosaurs were found in the western United States. That has nothing to do with anything for plate tectonics, and so that is going to be your best answer choice. Okay, number 9. Using the chart, which source of energy best fits X and Y? Well, I kind of have a problem with this chart because it says that the mantle is made up of melted rock, which we could consider to be a thick liquid. The primary source of convection energy, the reason why it says nuclear energy is because of this. In the inner core, the outer core, which is liquid metal, those metals are actually turning very rapidly. In the inner core, which is solid metal, those metals are breaking down, and as they break down, they release energy through radioactive decay. That's what it's called. And that is a form of nuclear energy. However, we don't really study that here in Texas. So I'm gonna kind of see if we can work our way through this. The primary source of convection current energy for the atmosphere is definitely coming from the sun. So we know that that is going to be solar energy because it's the sun that heats up the atmosphere that causes convection. And so we're going to get rid of anything that does not start with X as solar energy. So right there I got rid of 2 answers. So now I got to figure out in the ocean's made up of liquid, what's the primary source of convection? Well, I know it's not going to be nuclear energy because that has to do with radioactive decay or hydrogen converting into helium in the stars. So your best answer choice is going to be solar energy, which is that the Earth is tilted, and so it's heated unevenly by the sun, which causes the equator to be warm and the poles to be cold, which causes the ocean water at the poles to sink and travel down to the equator, which is warm, and that water rises and moves back to the poles. And I apologize, my allergies are going crazy right now, and so I am trying not to sneeze. All right, number 10, every year in late spring, NOAA issues a forecast on the number of hurricanes it expects to form the Atlantic Ocean. What are we basing that on? I mean, how do we make those predictions of how many hurricanes? It has nothing to do with air pressure readings. It doesn't have to do with the rate of evaporation, although that certainly is a distractor right there. Nothing to do with gravity. It has everything to do with water temperature because we know that hurricanes need warm water and to form. And so the warmer the ocean water is in the Atlantic that year, the chances of more hurricanes are certainly possible. Number 11, I did not like this question. I'm going to be honest with you. In which country is the following weather map most likely to be seen? I'm going to walk you through it, but I don't foresee this being a type of question on STAAR. I could be wrong, of course, I don't really know, but let's walk through it. In Great Britain, which is in Northern Europe, you're not going to have warm air coming down in a warm front because this air is actually coming from the Arctic. England is cold. We actually have warm air coming up from the Gulf of Mexico across the Atlantic Ocean and the Gulf Stream. So for Great Britain, I would have expected this to be a warm front and this to be a cold front. That would have been possible. So Great Britain's a no-go. United States. I'm going to have warm air. No, I'm going to have cold air coming down from Canada. Warm air is what would be coming up from the Gulf of Mexico. Again, it's an opposite situation there. China, same thing. China is in the north of the northern hemisphere, and China would have cold air coming down and warm air coming up. So again, that's not going to work. Australia is in the southern hemisphere. That means I am going to have warm air coming down, and this cold air is actually coming up from Antarctica. So Australia would be your best answer choice because it is in the southern hemisphere. All right, let's look at our vocabulary. A special map that indicates land elevations, and there is my clue word right there. That is going to be topography, and my best answer choice was J. A weather system that rotates and is associated with precipitation, that is rain. That's going to be a low pressure system. Low pressure brings us rain. Best answer choice was G. The process of moving sediments from one location and moving them to another is erosion. Erosion is what moves sediments. A boundary line of cold air is going to be a cold front. And a boundary of warm air is going to be a warm front. Theory that states plates are moving by convection in the Earth's mantle, that is plate tectonics, and that's really what Alfred Wegener never could prove, unfortunately. Weather system that's associated with happy weather, with fair weather. Happy weather is going to be a high pressure system. Remember, low pressure is lousy weather, high pressure is happy weather. And the rising of a gas or liquid due to it being heated, why, that is convection. The process of rocks breaking down into smaller pieces is weathering, and that is L. Energy from the sun that heats the atmosphere and oceans, causing the movement of air and water. So that is going to be convection in our atmospheres, and also in our oceans, and that is solar energy from our star. Okay. Lateral means sideways, so it's a sideways movement of water or air. I'm sorry, lateral means the movement of air or water caused by solar energy. That is going to be currents. We see that in waves that are moving across the oceans. And the blanket of air that surrounds our planet Earth is our atmosphere. All right, well, hopefully that will help you. And we're going to be moving on to day 9, which is organisms and the environment. Good luck. I know you're going to do fabulous on your STAAR test. So we will see you in the next session.